Hi, cool, it works. So guys, hi, I'm Abhishek. I work for Hubble. Hubble is like a marketplace for finding office space. So today I would be basically talking about like what kind of challenges we face at Hubble when we were working with like microservices architecture and how we try to resolve them. I would also show a little demo in the end for preparing like a real-time dashboard for like website activity or something. So this is the outline for the talk today. Quickly just introducing like microservices and talking about Kafka, giving an example, like a very simple example of running Kafka with Node.js, and then talking about KSQL, and then running a real-time dashboard, like a quick demo or something. So let's start from talking around microservices. I guess all of you would have, like in your lifetime, would have done like a monolith service, right? And over a period of time, we realized like we need to chunk it out. So like every service has like more like single purpose and it's more independent. And then you know like you can have like more technology diverse services rather than everything running on like Node.js or Python. Integration and deployment is much more easier. You can deploy like more continuously when you have like microservices architecture, and testing is also much more easier. So in terms of scalability, it really helps because it could be like some part of your services which need to be scaled much more quicker rather than other parts, right? So this is just like a quick overview of like having like, you know, like the pros about microservices, but then it also comes with a cost, right? So when you are in a monolith or something, you just have like one big service which you just deploy, it's not distributed. So whenever there's distribution, it comes with their own new problems like clustering. Then there's like a lot of operational complexity because now there would be like network latency. So a simple example would look something like this. Let's say you have like 4 services and all of them provide you like uptime of 99.9%. Then cumulatively, I mean, the whole system would have something like 99.5% after combining everything in the go. And then it's really hard to understand the eventual consistency in the whole architecture with microservices, because some service would be in a different state and then other service would be in a different state. So this is something what our microservices look like at Hubble initially. So imagine something like this, which is like a user management, and then this is talking to like an email service or a Slack service, and then all these services are doing their own request response stuff. So what happened here was like after a period of time, we understand like there was a lot of latency in terms of communication between different services, right? And then what we thought was like what could make this better was having event streaming in our microservices architecture. So basically moving all the non-critical mission services and tasks basically in an asynchronous method. So now what happens is, let's say this is a user management service, then it would just basically emit like an event, like a user is created or something, and with the schema of that user, and then a different service like email service would just listen to it and send like a welcome email. So this is something currently what our infrastructure looks a little bit like at Hubble. This is not the whole picture, just like comprising of basically 3 services. So I'll just quickly talk through like how we are using it in our company right now. So let's say, you know, we have this user service, and then the user service is basically creating like records in these 2 topics, which is like user created and user updated. And these 2 records are basically being like consumed by different services like email, Slack to send like Slack messages in the group or something if there's a new sign up, or and then there is like a user enrichment service, which basically what it does is in the background it tries to find more information about from your email or from your Twitter handle and would update automatically your profile. Then there's a HubSpot service which basically creates like tasks for customer advisors to get in touch with you if you, let's say you're basically a high profile customer from which we get to know from our user enrichment service, and we would basically get, like you'll get a call from our advisor to more understand your specified needs. Then there are different services like calendar services, Then also like we have one different service which is a huge chunk, which is like listing service. So at Hubble what happens is whenever there is a new office space, you can publish like office spaces on our platform, and then you can go there to view these office spaces. So what happens is, let's say whenever there's a new office space, we need to update our search, right? So what we do is like we basically create like a listing created event, and then there's a search service which is listening to Kafka, like consuming messages from this topic, and that would automatically update our search service in Elasticsearch, and then that is basically serving directly in the front end. So this is a quick overview. So now I'll talk about Kafka. I've been saying Kafka, right? Like what exactly it is, what it does. So before like introducing Kafka, why I want to put more focus on like why Kafka, right? Like why does it make sense at all? So currently it's being used by more than 1/3 of the Fortune 500 companies. Companies like LinkedIn, Microsoft, and Netflix process more than 1 trillion messages per day last year. So this is what like scale looks like at Kafka. And then just one example, like quick example. So Spotify actually resolved their log delivery issues from like 4 hours to like 10 seconds to Hadoop from Kafka. These are just some of the other companies using Kafka right now. So what exactly is Kafka? Kafka is a distributed partition replicated pub/sub messaging system. So what do I mean by that is, so we need to understand what exactly a publisher-subscriber messaging system looks like, right? So in that system, basically you have like different publishers which basically produce like these messages to a topic or a knowledge base. And then there are different subscribers or consumers which basically consume these messages from your topic and basically use these messages wherever it's required. So what Kafka does is like stores messages in topics which are partitioned and replicated across multiple brokers. And then producers send messages to topics which is consumed by consumers, which could be in a consumer group. We'll talk more about this stuff in coming slides. So there are basically 4 core APIs around Kafka which does all this jizz and jazz. So there's Streams API. I'll talk more about the Streams API in coming slides. Connect API. Connect API is something which is used to connect like your data warehouse directly to Kafka, or basically getting the end output from Kafka to your data warehouse. And then you have producers which would basically write to different topics. You have consumers which would basically consume from different topics. So I like this Unix analogy which Kafka basically provides something like this. So if you see here, this is a very simple Unix bash statement, which what it does is it's taking like an input from a file and then searching for what Kafka, transforming, producing, doing some transformations on it, and then outputting a new file, right? So what we can see here is this is something like a Connect API, which is basically producing data from you, from your file, and then this is basically passing, this pipeline is basically passing this data to the next operation. This is something like a producer would do here. So this is Connect API, this is like a producer API. And then you have something in between which is like a KSQL or Streams API, which is trying to make sense out of it, or like running map reducer functions to make it more enriched data, or basically process your streams to understand like what's happening there. And then you have this another pipeline which is basically sending out data, which will be like consumer, which is again being consumed in a different stream, and then you have the final output. So I quickly want to talk about like how actually Kafka store messages in these topics. So every topic would be like partitioned in like n number of topics. It depends on you how you want to, how many number of partitions you want to create in your topic. So let's say, you know, like when a producer is writing to these topics, what will happen is it could either write in a round robin way, so or you can select like which partition you want to write to, or you can send like key value pairs, then it would keep writing to one particular topic for that key. So what would happen here is it would always be like an append log. So let's say when your producer is producing messages, it would always like keep appending messages at the end of one partition. So every partition has its own sequence, which it basically keeps in memory. So you would have like something like, it starts from 0, like 1, 2, 3, like an array or something. So it would keep appending in front of it, and it's scalable because it's like replicated in clusters, so you can have like multiple clusters having the same partition on multiple clusters. So basically your data could be much, much bigger than even the size of that cluster. So all the writes are like append only, and reads are single seek and scan, because what happens with Kafka is when you're consuming your messages from Kafka, what would happen is like consumer would send like which partition and which topic I want to consume from, and it would then can start from like this offset or this offset, or from here like where it wants to begin. So this is more of like basically a Kafka cluster. What does it look like? So in this Kafka cluster, we have like 4 brokers right now. In this Kafka cluster, so with this 4 brokers, so I have this topic, single topic right now. This single topic has like partition 1 in my broker 1, and then partition 2 in my broker 2. Like, so you can see like these have, so every partition is replicated twice right now. And so partition 1 is replicated in broker 2 and broker 3, and this is my lead part. Basically, this is my leader of this broker, which is for partition 1. So what happens in Kafka is like whenever you would write to a topic, it would write to the leader of that topic. So it would write to that leader of that partition, and then this partition is responsible, like this broker is responsible for replicating it to like broker 2 and broker 3. And then in case of like partition 3, if you want to write to partition 3 for topic 1, then what would happen is like this leader would be responsible for writing it to partition to broker 4 and broker 1. So this is something like how leader and follower works, and this is something how like Kafka does replication. So in terms of consumers, what happens is, so you have these topics now, and you have these 3 partitions in here. So in a consumer, you can have like multiple groups. You can have like multiple consumers in one group to scale your consumers. And let's say right now we have like 2 groups of consumers. So this is like group 1, group 2. So in group 1, you can see like there are 2 consumers right now. So this consumer 1 is consuming from partition 0 and partition 1. And then in group 2, you can see like there are 4 consumers right now. So one consumer is not doing anything right now. So what Kafka does is like it basically does one-to-one mapping to your consumers. So if you have more number of consumers than your partitions in it, basically your consumers would be sitting idle in that certain case. But what happens also here is, let's say one of your consumer goes down in that consumer group, then it would automatically start using consumer 6. This is not something which you would have to maintain. This is something Kafka would do it for you. So this is a quick script like how you can run Kafka with Node.js. So Kafka is available on Homebrew for Mac OS, so you can just install it using brew install Kafka. And then I'm using a library called Kafka Node right now to basically run my consumer introducer. This is a quick script which what it's doing is it's defining a new client. You would basically pass in the endpoint for your client, like the server where it's accessing it. Right now it's local, so I'm not really passing anything in there. Then we have basically a topic information. So your topic which you want to write to, the offset where you want to write to, the offset where you want to read from, sorry, this is a consumer. And then basically I'm defining my consumer, like a high-level consumer, passing it the client connection, passing it the topic where I want to read from, like the topic name and topic offset, and then some other options which are configurable. I'll show a quick demo around for this also. And then there's producer. What producer is doing here is I'm instantiating my producer with like high-level producer API, passing in the client connection, and it basically has a method called send, where you basically pass your payload. What payload looks like is something like topic, like basically your topic, your message, what you want to pass to, and partition. This can be also done in a round-robin way, but in this one I'm just sending, I just have one partition, so I'm just sending my messages to one partition. So you can actually put this thing quickly in Express, and what it would look like in Express is something like this. Sorry. So this is currently running here. So what I can quickly do is I can send some message to my endpoint, which is called send. So if you go back here, you see like this is the endpoint send, and I'm just sending my topic, my message, and which partition it has to send to. And then I'm generating the response in JSON format so it can consume like in my REST API. Postman. Cool, so here's basically my endpoint send. I'm just sending some information there. Let's say I can change name or something. Ravi. I'm sending the ID, location, and name of my user when it's logged in. So you will see right now, like Kafka replied to me, like now the offset is 14, and this is basically sent to a logged in user topic. And you can see the same thing. So a consumer was also running in background right now, and then you can see the same thing here. So it's being consumed here. So where you can see like Ravi, offset, the partition, and the next offset for my topic, next offset for the same partition. Cool, I'll go back to the slides now. So where exactly now Kafka make like good use cases for us? So this would come very, very interesting. So actually New York Times, the newspaper, they use Kafka as a storage system. So what they have in there is like they have an underlying Kafka running all the time. The cluster basically serves on the CMS. So they have like all their articles from like day one till now, which comprise something like last 50 years of articles. Why it does make sense is because this is what Kafka is good at. Like Kafka is good at storing and searching, right? So what it really does is it builds up, like the CMS basically uses something in like KSQL, which I'll talk more about in future, in upcoming slides. And then it basically streams all these content directly to the CMS, which is served to end users and inside the corporation itself. Messaging, so this is what we saw with Hubble, right? Like we basically introduced as a messaging system, so we could decouple mission critical and non-critical services. Stream processing, this is something which you would see in my demo also. And then event sourcing, activity monitoring, we are going to build this one in the end. And then, so Kafka recently introduced like exactly one semantic. So it's actually pretty interesting how they are trying to handle exactly one semantic, because it's quite a hard problem. So they do solve it on some level, but it's not yet fully solved. So what happens is, let's say if your consumer fails, and then before failing it basically doesn't commit like you read through this offset, you can't restart from that offset. So that's why you can actually read like one message twice, which you can handle in some or the other way, but this is still like more questionable. So then Kafka Streams API. So I think this is one of the most interesting parts around Kafka. So initially when Kafka was around here, you would either use the consumer API or the producer API to produce your messages or to consume your messages, right? And then you would use something like Spark or Flume or something on the top of it to stream your messages and do like event processing. So I think in like 0.9 or something, they introduced Streams API, and then you don't really need to use something like Spark. You can actually do all of the event processing directly in Kafka inside. So in Streams API, there are majorly two parts, like two abstractions, which they divide into. One is a low-level processor API. What it does is basically used for like data processing, composable processing, and maintaining like local state. And then there's a high-level K-stream DSL, which is subdivided into like K-streams and K-tables, which is something also like KSQL uses to have a SQL engine, which you'll see in next upcoming slides. So I just quickly want to talk a little bit more about like K-streams DSL. So when you would actually try to, let's say, use stream processing in Kafka, you would basically be interacting with this one, which can run like a lot of map reducer stuff for you. So you can literally run like map, filter, join, and aggregations on this one. So they are basically like these two abstractions which K-stream API, K-streams DSL uses. So one is K-stream, which says like you can have a stream of records which would be immutable. So something like which would never change, you can't really update it, so it's basically like a log. But then there is another thing which is called K-table, where they keep like a track of like key value pairs and keep updating your records on the basis of those values. So it's basically like a mutable structure. Cool, K-SQL. So it looks good, it sounds good. What exactly it is? So K-SQL is a streaming SQL engine for Kafka. And what you can do is you can write like SQL kind of a syntax to run your, or to process your streams using Streams API. So so these are the two things which K-SQL introduces is like you can either create a stream or you can either create a table, which is part of high-level streams DSL, which we just saw in the last slide. So if you see, like, stream is basically an unbounded sequence of structured data, which is like facts. So you can't really update or delete a record. You can just keep adding records. And then table is something which is basically a view from like another table or your stream or something, which would be like a collection of evolving facts. So something like a key value pair where your values are updating over a period of time. So the syntax would look like very similar with SQL. So you can see like what I'm trying to do here is I'm creating a stream of page views, which I'm also defining my schema for like, so like view time would be a big integer, this would be user ID is a varchar. So you can actually define something much more in depth, like basically your type variables. So now I would give you a quick demo to run the whole thing, and I think Joana would help me here a little bit. So what you can see right now on screen is I have a Docker container which is basically running Elasticsearch, which is running Grafana, and then running Confluent for my Kafka instance. What we are going to do here is I'm going to create a stream of click streams right now. So click streams, what does it mean is, so all my users who are trying to access resource on a website or something. So this is basically a click stream, and I'm just reproducing like events like 500,000 times, so it can keep running and we can still see data around it. Now the next one is basically producing like the response one. So in next one, what we want to do is, so this one, what it's doing is it's now generating like clickstream codes. These clickstream codes are like simple HTTP request response headers like 200 like success and stuff. And then I'll have one more stream of data which is for all of my users. So this has like also initially my clickstream data basically has something like a user ID, the resource they are trying to access, and and then this user table that explains more about these like users itself, like the username, the full name, the location, and the type of the user, like which plan they are on. Now I'm going to run my KSQL server. So KSQL basically is kind of an abstraction, or it's like a SQL engine running on Streams API. So you would have like KSQL which is running as your server, and then to interact with it you would have like KSQL CLI where you can run your SQL statements. So this is something what your SQL the CLI would look like. So here, what I would do is I already have a script which basically creates like different tables and different streams, which we just talked about in like last slide. I would run that. I would also show you what it's exactly doing in that stream. So currently I just ran this basically my SQL schema, which is creating a lot of tables. Let me just quickly show you those. So if you see here, then what I'm doing here is like if there's already something, I'm just dropping them, and then I'm creating like a click stream which has like my time, my IP address, the request, status of that request, user ID, the payload which you send in the request, how big was that or something, and then I have this whole thing which is in my topic click stream. And then the same thing for like, I'm now trying to calculate like events per minute or something, which by which what I want to do is like, how this user ID, how many events did he send in like 10 seconds or something. So this is just like a set of SQL queries which I'm running to create my streams or tables. So streams is something which is appending all the time, and then tables is something which is also updating at the same point of time. So coming back here, what we can now do is we can list like all the tables here right now. So these are all the tables which I've created from my SQL script for like my web user, errors per minute or something. And then I have like my streams, which looks something like this. So what you would see here is like, if you would understand from here, like table is something which is more of like an aggregated view for my application. So imagine something like where I want to understand like errors happen per minute in the application, which is an aggregated view for me rather than like an append thing, because this would keep on increasing also every time, right? And then stream is something which is just like an append log, so something like user click stream, from which I'm actually calculating my error per minute or something, because you get like a status response from there. You can also see like one of these tables. Let's just see like user click stream, what does it has. So the syntax would look like very familiar. I'll make it bigger maybe. So you need to append a semicolon like SQL. Oops. Not exiting my process somehow. Cool. Let's try to view data from some other stream maybe. So I think what's happened is like my machine is running out of resources because it's running on a Docker container right now. But what I actually wanted to show you here is like once you see these tables or like streams, what would happen is like it will keep appending more data inside it or keep updating this data. So what would eventually happen is like, so normally in SQL you would have like once you do your query and you would get the response or data inside, right? But that data is not growing. In KSQL, you would have data streams which would be having like new data every time, every second. So until you don't stop it, it'll just keep running in the background. I'll actually now try to port whatever I have in my KSQL streams and tables. I'll try to port it to Elasticsearch, and then from there I would try to spin up a Grafana's dashboard for you. So what I'm doing right now is basically I'm creating like my previous stuff and then just creating basically using like Connect API. I'm trying to connect my Elasticsearch service, which is creating, which is basically reading data from my streams to Elasticsearch, and then I would just be charting it out. So. While this is running in background, we can do some questions. This is a little slow. Do you guys want to ask any questions or something so far? This is almost the end of my presentation. Yeah, I see so many questions.
Do you have any experience using Kafka Connect or Videographer to stream data stream?
So actually what we, sorry.
To stream data from your data warehousing, like some relational databases?
Yeah, so there's actually a package in Node itself. I can't really remember the name of it, but I think NodeFluent, like an organization, they have like a package called Sequelize or something, like Kafka Sequelize. What it does is it uses Connect API to connect to your data stores like from MySQL or Postgres or something. So this is something which we are doing right now at Hubble to basically read all of our data from for historical records. So we just deployed this back like 2-3 months ago. It's running good now. It's much more stable. But we want to have like all our previous users also with like different services. We just want to use like Connect API to have them over Kafka. Does it make sense?
And just a quick note, we need to finish around 9. So one question and you go.
Okay, cool.
So we're actually in the middle of trying to decide on something that can orchestrate different microservices. And so this is one of our considerations as well.
Yeah.
Some of the other ones are Kinesis and Conductor. Did you guys take into account other alternatives?
So actually we did like go around other alternatives, and what we find out was like with Kafka there is much more less DevOps, because they are like, if you use Confluent or something, they provide you much more much more managed environment, right? And you can actually invest in that rather than investing in DevOps or like wasting your time around like just figuring out what's happening in the cloud. So it does make a lot of sense to use Kafka. I do understand like it's still like not very mature, like it's maturing with time, but I think a lot of companies like Twitter, LinkedIn, everybody is using Kafka, right? And they have already figured out that ballpark. So it's just like, it's not with everyone right now. It's like all the big companies are already using it, right? So you can actually trust it.